everyone, how are we doing? It is start of coding in our week 4. So let's take a look. Who's in the chat? We got to wake up Mubot right here. If you're in the chat, feel free to say hi. We got people working away right here. Nice job. Let's see. I think people are Cor Demo. The points I'm trying to do. I was trying to make a line. I think there might be a big issue with this. When is your... I might try to fix the code live right now on Stat 201. I think I've seen this before. I don't know. Hey, Shreya, good to see you here. Drop your questions in the chat. We got a Core Demo issue. I might try to fix Petrie's code right here. This is Petrie's code, but I think it's having problems with the newer version of R or something. So I might try to fix this live right here. I've got until about 4:40 or so, and then I've got a meeting at 4:45. Drop your questions in the chat, though, so let's try to fix Core Demo. Can Brian fix Petrie's function that got broken by the update of R? Don't worry, it's R that it's worked for like a decade almost, and then I think one of the R Studio updates has caused an issue. Can I fix a function? Probably not. Working with Core Demo. Let's take a look. Also, question 5 on Discord. I'm missing something. Question 5. Let's look at some question 5 here. So we'll do this for a moment right here. BS474. Shout out to Dr. Petrie. It's really, Red Class is absolutely awesome. We want to do some updates to it. So question 5 right here. But I think Core Demo has been having an issue. Sent the Q5. We'll be checking that out. Working on Q4 on the homework. Can we go over the overview? Yeah, Q4 overview. We'll do that here next. Q4 overview. And Q5 overview. Okay, let's check this out right here. Let's go look at some Core Demo. Okay, and so I have to say, I mean, a huge thank you to Dr. Petrie who wrote everything inside of Red Class. So if actually we probably do question mark Red Class, probably says it. I'm working on the pivot chart assignment. Yeah, let's look at some pivot charts. You want to look at some pivot charts, Ivana? Well, this is for only coding, so I have to do it with code, which actually I figured out how. I got the hiccups. I figured out how to do that, but let me know your questions, Ivana. What you're thinking about. Last class we did the first one. No worries, Ivana. Ask away. I'll try to answer it while we talk. But no, Ivana. Let me throw 8,000 points. Don't worry. Like this is the special office hours for coding. I should find the code that. Hello, Nicole. Good to see you here. We're gonna try to fix Core Demo, and then we're gonna do some more 474. Gonna say anything about? I don't even know what I did. Okay, so Core Demo is causing people's issues. When you use Core Demo right here, see it's doing this weird thing where it's clicking in the wrong spot. I've noticed that. I don't have my students using Core Demo this semester. Also a problem with Q5. Q5 will be doing Q5 here soon, but you notice how it's clicking the wrong spot? Let's see if we can fix this. It's gonna have problems. Oh my gosh, it crashed R. Okay. So let's look at Core Demo. We need to reload. Library. Red Class. We're going to spend 5 minutes on this. And if I can't solve this in 5 minutes, we'll come back. We're going to do other stuff. Okay, let's see if we can get this. Core Demo. Does anyone know how to look at a function? If you want to look at a function, you can look at a function that a user has made by running it without the parentheses. So this here is the Core Demo function. It has a default. Yep. It has a default. So we're going to store the function right here, and it's 63 lines of code. So where is it getting mad is the question. So it has to be getting mad. Like this is the while keep going, like while it's asking you for points. So plot, there's the plot. It needs to get the user input, but the user input is getting wrong. New point points. If new point 2. Oh, so this is where it tells you the color of the point. If not, okay, so if the new point, if you've entered in your second new point, if else, we're in an if else right there. Stores into our old, else keep going 0. So That's where it labels it all. How's it grabbing the clicks? That sets the plot window. The X limits, the color white, Y limit. The X label, the Y label, the main title of the plot, the size of the points. That's character expansion right there, size of points. Creating a rectangle, no border, text, telling it what it says, rectangle, no border, text. That's all the creation of the window stuff right there. Creating a vector of X and Y that are blank. Creating our old 0. Keep going is set to 1. While keep going is equals 1. Okay, so this is where it starts to enter in. Locator. That looks to be a function I don't know. So, hey, what's up, Jesse? We're going to get working on some 474 here in a moment. I'm going to see if I can fix this and maybe post it. Unlist locator. Okay. So, locator, I think, means if you click a plot, it looks like probably what they did, plot new has not been called yet. So if we go to plot 1, 1. Oh, look at that. That's super cool. So what it is the locator. Let's see if it clicks where we click. So what we want to run is run locator again and click right here. Look at that. Do you see the issue? Who notices the issue right here? I think we found it. Look at the issue. Try to see if you see the issue when I click. I'm clicking right there. And what do you notice? What do you notice about where I clicked? So think about the issue, and we're going to fix this, I think. I think we can fix it now. So what do you notice is the issue? So look where I clicked. I clicked right here. Or let's click right on that dot. That's probably even a better thing to do. Let's click right on the dot right here. And what do you notice? It's not on it. The X should be 1 and the Y should be 1. So let's take and do offset right here. And so this right here, we could do a calibrate on it also. We could set a calibrate button. But then they'd have to click calibrate or say, do you want to calibrate it? Okay, so it'd be like, do you want to calibrate? Click the dot in the center of the screen. So we could set a calibration metric. So that is the offset right here. So wherever they click, where's the function? Okay, so here it is right here. It's going to take if new point, unlist the locator. So the locator is giving those positions. Well, locator is storing, let me look at what, locator stores a list, and then we're unlisting it. Okay. So we unlist locator into new point and new point 1. And then we want to take minus length X. So whatever we store into X, here we want to go to X, and X needs added to it. Such a band-aid over it. X needs X plus this, and Y needs Y minus this. Okay, cool. Yeah, it's -1, so I should just realize that. So now we go to Y minus that. Okay. So now when I run it, there's the 5 minutes. Did I do it right in time? Core demo new. Okay, so now we have this. Let's run core demo new. Ugh. It should be. Is it further off? Did I reverse it? Oh, let me copy this. It's going to crash my R again, I think. Or. I wonder if it is. Okay, give me a second more here, because is it just going to be. This is so close to how to fix it. Do we need to subtract this? I did minus. That should overwrite the X and the Y. And then plot. Let's new point. Oh, because we're unlisting it there and new point. So we're unlisting it there and new point. The new points are used down here, right? There's where new points are used. So we need to take the new points The new points also need this done to it. The core, yeah, it doesn't matter here. So new point position 1, new point position 2. Yeah, there it is right there. And the new point is being concatenated onto the X vector. So new point needs to be overwritten. And each time it does it, it's creating a new point. Do we do it the other way? So I think we need to overwrite the new points. I think what's stored into the first new point. What was our offset on that? I gotta save that offset first. New point 1 should be X, and new point 2 should be Y. So new point 1 is going to have new point 1 minus this. I think that was plus to begin with, and I changed it. And then new point, we're going to overwrite it here. New point 2 is going to be new point 2, subtract this. I think it was too high. And that might do it. I wonder why the locator is off. I don't even know if R knows that. Because it's not Dr. Petrie's code. It's totally this. Okay, so let me copy paste this again. We go Core Demo New. Ooh, we're further off. I think it's just in the wrong direction. Okay, so I think if I go to the minus here and plus here, and now I run Core Demo New. So I need to move more to the right. Hopefully it's not like different every time. Maybe I just have these reversed. Let's go here and just... Yeah, it's like... Let me try and subtract more from this and see if we get closer. No, further away. Is it in the right spot now? It's that far. If I click this, if I click 0.4, it's over there. So if I change this to 0.2, so that must not be... Oh, yeah. That's at... So if I click down here on the baseline, it's at basically at a little bit below 0.6. So is this moving it is the question. No, I don't think I moved it. It should be overwriting it. Unlist locator. It should be overwriting new point right there. And maybe we need to write over the X and the Y too. Last try right here. So minus length of X. X is equal to 1 and add from the other. What do you think we should do, Shreya? We're like so close to this. Let's see if we can get it to move right here. It's not moving it. Or maybe if we go down here to where we plot it. So let's go to where it's being plotted. The plotting, well, this is where the new points, because when you click it, yeah, because the click is what's being, it's the locator. Like when I run locator here, it's the problem. So the locator, so I just ran locator right there and it located all those points. But clicking here on the graphic, this should be at 0, 0, and it's not. So locator you can run. Let's type something real quick. I'm going to give it 5 minutes tops. Then we need to switch topics. Locator. So like instead of adding to both, can we just try having the same subtract? Yeah, but so the issue is locator visually shows you where you click on the screen. So it's registering the clicks. So when we run locator right here, like if I locate this point, when I click the screen, it's going to plot that point where it's at. And, oh no, that's just locating the point. So what if we do locator 1 plus 1? No, it doesn't like that. unlist locator 1. Okay, there's a vector plus 1. Ah, look what we did, Shreya. Do you see that right there? So we can do it right there inside the locator. Does that make sense? So you see how where I clicked almost in the same spot. Now we're getting somewhere. Okay, so let's delete off all this nonsense here. And now let's try to go into the locator where it's unlisted, and we can just add to it here. So the problem is this is a constant, but we want to add one value to the other. So let's do 0, 0 right here. And then we run this now. We're way off the error locator to non-binary argument plus unlist locator. It should be doing the... Okay, so unlist locator. Oh, because that's in the unlist. Okay, we don't want it in the unlist. It's the parentheses issue. We want to close this off and then add to it here. Okay, good. So now can we move the point over? We're clicking here on the bottom here. So now can we move the point by going to the X and the Y? So this should be the X. Can we add to the X and do this? Boom, Shreya, we did it. That's it. And these are the values I think we were looking for. Look at that. Like it. So that's about 0.58 on the Y. Ooh, negative. What am I doing? I'm adding. Too low. Too low. Tiny bit too low. We'll be looking at a locator. I wish it's a pretty cool function. I didn't even know of it till I started doing this right here. I'm gonna move that a little bit more to the right. Go here. So a tiny bit more to the right and a tiny bit up. Tiny bit more up. Tiny bit more up. Tiny bit to the right. If we're gonna do this, we're gonna do this right. Tiny bit more to the right. It needs to go a good bit more to the right. No. Whoa. Is it not consistent? Wait, what happened? What did we change? Something went haywire. Oh, is it because the 5? Wait, is it not consistent? It's way out. It's got to be the... So we had 4 right here. I gotta... So now we're too... It's not consistent. It's not consistent. It's where you click. It's not a consistent error. Yeah, looks like we can't do it because if you click down here, see it goes right and left. I don't understand. So it's... Let me Google real quick and that'll be the end of it. So it's not consistent. Should have Googled in the start. Locator returns incorrect graphics with graphics. Did no one figure it out? So the locator thing... Yeah. Oh, so the zoom settings. Okay, so let's try that. View, zoom. How do we set zoom to 100? This is the last try here, Kayla. So how do we set zoom to 100? View, tools, global options. How do I set zoom to 100? View, zoom in. Doesn't say the zoom size. Zoom out. Zoom out. Actual size. Okay. Core demo. Has to be at 100. Okay. That's the answer. Let me see right here. Can't take a screenshot of this. It's a bummer. So you have to go to actual size. Problem solved. Let me send it to this person, David. Found a solution. You have to go to view actual size, then run core demo. It's an issue with a function inside core demo that locates points. It only works when the screen is 100% size. Actual size can fix this. Here we go. We got it fixed. Can you screen record it? Yeah, so it's so weird, right? Well, I guess it's hard because it's on the other screen. But thank you, Shreya, and everyone for hanging out here while we did this. Let's jump back over to your assignment. Thank you so much. I really wanted to solve this because I don't know. It's like it's been bugging me, but it's a thing with the locator code. For some reason, the zoom, like I could take a look at the locator function and see what's going on with that. But yeah, pretty crazy, right? So that was us debugging a function right there. 100% nothing to do with Dr. Petrie because locator, for some reason, like with RStudio or whatever, the people who wrote the locator function have an issue. So since Dr. Petrie's code references locator, which I didn't even know what locator really did, but it's such a cool little neat function. But because locator has an issue, that caused an issue for the core demo function. So it's pretty interesting, right, Shreya, how something can break. Awesome. David's helping Landon right there. Awesome. So we were able to figure that out. Thank you for hanging out while we did that. You got it solved in one way soon. You got let's go right here. Which one should we do first, Shreya? Which problem should we do first? 36th version of the homework right here. Which part should we do first on this? Number 4. Let's go look at number 4 right here. We got just a little bit of time to do some coding today. 23, 53. Here we go. Number 4. Is that the cosine difference? Number 4. Write a function called cosine difference. So when we're doing this function called cosine difference, here's the best thing to do. You want to be able to solve this function for smaller versions. So if you look at, it's got the code basically here. It's got basically how to do it, but you have to be careful because if you're taking two vectors and multiplying them together, like, can you do this right now? Can you tell me the cosine difference? I no longer have it written from yesterday. Can you tell me the cosine difference of vector x1? Let's just call it x for the moment, which is going to be 4, 6, and vector y, which is 5, 8. I'm going to take a moment and try to find the cosine difference here. Actually, I'm going to make my numbers easier so I can multiply numbers and square them easier. Can you tell me the cosine difference of this? So take a minute and compute the cosine difference. So we'll put on our thinking music. Compute it. Go through here and compute. So let's do it. You ready? 1 times 2 is 2. Plus 3 times 4 is 12. That's 14. Right here we have square root of the first vector squared. So this is 1 squared, which is 1. 3 squared this, that's 10. That's square root of 10. Next we have after that times, and this should be divided. Divided by times this right here. We probably need to put this into a parentheses. Square root of, and the second vector squared, added up and then square rooted. So now we need to take this right here. 2 squared is 4. 4 squared is that. Is 16. That's 20. Square root of 20. And there it is right there. It's the sum of the second vector squared. Well, now what we need to do is we need to write this, but write it with code. So now we've got the answer right here. We do 1 minus that. That should be the answer. Does that make sense? I now have an answer, which I have checked. And I could even put the numbers in here, but I've solved it. And now I need to code this. So that should still be the same answer. So now we need to code this. How can I get 2 vectors squared and then summed? How can I get 2 vectors squared and then summed? How can I get 2 vectors squared and then summed? I've got an x and a y and I want to square them, then sum them. Or multiply them, not square them yet. I want to multiply my vectors and then sum them. Like I want to sum the vector, multiply the vectors together and then sum up what the products were. Sum of x times y. Oof. Oh, because I don't have it stored. 14. So we just confirmed we did that part correct. This is how to do it to be like, okay, that's working. Because what if x and y was a longer vector right here? Like what if x and y had more elements in them? Like this right here, is my code still going to work? I mean, I don't want to figure out that answer by hand, but did that work for that longer vector? So this is why you want to use like a shorter vector and then figure out how to do it for the vectors, just like that. Does that make sense right there, Shreya? So we've now done that, and the vector length,
it doesn't matter.
The vector length doesn't matter. It's going to work for any of them. So we have right here the confirmation of our first answer right here. So then next, we need to divide by, and we need to take the elements of x, square them, sum them, and then square root them. Be careful on the order of this. We need to take the elements of x, square them, then sum them, then square root them. So what should we do here? And I do this all inside of a parentheses. We need to take the elements of x, square them first, because that's the vector, the first vector we're dealing with right here. The elements of x, square them, sum them, and then square root them. So square them, sum them, then square root them. Even though I'm saying in that order, you want to reverse it because you're going to go, the inside thing happens first. So you want to square root them, sum them, square them. Great job. So square root sum of x vector squared. And if you look at this right here, we can confirm that this is 120. Dun, dun, dun. It's because I stored the other vector. This is 10. So do you see how we're confirming our answers right here? So like, this is what you want to do, is you want to get it to work. I'm going to stop writing the rest of this, but notice now we could still do this and we could make a much longer vector. But the reason we're not using a longer vector, and we could do it right here like this and still confirm that it works for any length vector, is because I want it to work on a test case. I want it to work on a thing I know the answer of. So when I work on this right here, I know that I'm squaring x and summing it up. 1 squared is 1, 3 squared is 9, 9 plus 1 is 10, square root of 10. So when I run x inside of here, I can confirm that the sum of x squared, which is 1 squared plus 3 squared, is going to be 10. So the next part should be easy with the other vector. But then we're going to turn this into a function where we just give the inputs, because we're basically building the skeleton of the function right now. How's this looking, Shreya? Do you feel better? I think a lot of people are stuck on the writing of the function part of this, because once you get the function written, it just takes the inputs. How are we doing right there? Yup. You're welcome. Yeah. So this is a huge thing right here. Like, if you so it's just vector mathematics, since we can just do the multiplication or multiply vectors, add vectors. So you don't have to worry about going through like elements. Like you could do it really, someone probably do it with a for loop. Like for the length of the vector, multiply this by this, and while the length of the vector, you could do it with a while loop. But the vector mathematics will do it for you. And then you just want to do like error messages if like other stuff. But awesome. Should we look at the other one here? What other things should we look at? Always be running your codes in those little bits and doing confirmations. Run your own sanity checks. You'll go insane without sanity checks. What should we look at here next? What should we look at next? Oh, I might drink a third cup of coffee today. Cup of coffee number 3. I think you said number 5, right? What should we learn about number 5? Number 5. A function called leaps. We got about 8 more minutes for function number 5. I think number 5, I think Nicole also had some issues with it. So which issue are you having right here? So with the way leaps works is we're asking with this vector right here, what is the difference between two values if you like leap a certain amount? So the best way to understand it is to do the leaps function in pretend. So if I were to have the leaps function here where x is the vector 3, 1, 8, we should think of the return of the leaps function. Now the leaps function would take x and say leap by 1 and tell me the differences. Differences are always reported in absolute values. So what would be the return of this function? As default, I am creating a function. I think the default is actually, it is 1, right? Just want to make sure. And lag is 1. Yeah, lag is 1. So lag would be 1 right there. So you could say lag equals 1. If your function were to work on this, which the default has, it has a default, or you could name the thing, and returning is not showing issues. Oh, is it working or not showing? So the return on this right now, the return if this were to run, which is not going to run because there's a leaps thing that we're not using. You meant to show 888. Wait, I'm confused. This one right here will return 2, 7, or rather the output would look like position 1, and then it would say 2, 7. So it would return the vector 2, 7. It would look like that. If it were to run, it would do this. It was typos, was it? I'm trying to see. What would leaps, 2 do for lag 2 of this? Now, don't worry that the leaps function is not running. I'm just showing what this should do theoretically. It's going to go and it's going to go from this one to this one until the leaps. It will return 5, exactly. So you understand what it's returning because it's going to return, if you were to go 2 elements over on that vector, it would return the difference. So if we added another item here like 1, it would return 5, 0. And this one would also return right here 2, 7, 7. Because the positive or negative,
It doesn't matter.
it's just returning the absolute value. So if you think about what you have to evaluate right here, you have to take the elements of x. And when you're doing this, you would want to go right here and go to x, position that you're evaluating. And we'd actually want to start this off on. You got to be careful where you start it. We'd want to go 1 plus the lag we enter in. So now we have 1 plus the lag. And now that's where we're starting. That would be the first element we evaluate, would be 1 plus lag, because lag is 1. And then we would compare that to position 1. And so if lag is equal to 1, that'll run. And that returns the value right there. Probably want to call this I or something. Because if I... Just thinking. I guess I could add an I. Start I at 0? No. Well, I could start I at 1. I think I'll start it. You didn't add the lag? Works either way. So if you start right here at 1, one can start at I. Whoops. So that could be I right there. But this needs to move forward 2. So we could go here I minus 1. So there it is right there. Well, no, we don't want to do that. We want to go plus I minus 1. Okay. I think that'll do it. Let me double check. Because I want this to not add anything here. Whoops. Didn't run it. That's the first position. That's the second. And if I change the lag right here, now we go right here. I feel like I minus 1 is pretty ridiculous. That's starting on 2. We don't want that. That's not right. This will go to 3. That's good. So we want this right here to be on 1 every time. So why was I using lag there? We don't want that. We want this to start on 1, so it just should start on I. There we go. And so now, if we do this, it's 2. And if we do lag, or if we do the second one, it's NA. 7. If we do the third one, negative 7. Good. So I don't have this... well, we could, if we do a while loop, we would want to overwrite what I is. If we do a for loop, we can just have it run for a certain length. So if you use the while loop, you'd want to put in something that increases I that goes while the length of the vector or something like that. But this is some of the theory behind what you need to be writing right here for this one. I don't want to write the full thing, but if you notice, I'm getting it to work on a test case. Every function I write, just look at how we were doing the locator thing. We were running it like 50 times. So I don't teach you how to do these things where I run my code about 50 times. My function is working on all except leaps. I'm getting the fourth element in my vector of 3. Are we supposed to get on the test 3? I'm getting fourth element in my vector instead of 3. Let me take a look. Okay. So this is when you put in, and this is the test case right here. The test case is the following values. So if you're running right here, you're saying you're getting a fourth element right here. And your fourth element is, what's the fourth element? Because if it's doing 2, then it would find the element here of this. And your fourth element, I'm guessing, is, because it's doing a leaps of 2, 0.8, right? 0.8, yep. See right there, 0.8. I think it might actually be a typo. Jerry, it's great work right there. Let's throw 1,000 points. Let me think. So, because you're not supposed to really enter an integer, non-integers into this. 1,000 points. Good question. So let me think. What you could do, because I think that's the only one. How could you add to this? So you could get it to work. Please tell me if you think the grader grades you wrong. But you could add inside of here, if whatever someone enters in for the lag, when you divide by 1, if the lag divided by 1, their original entry to lag, when you divide by 1, it's not equal to 0. So if when you divide by the lag by 1, it's not equal to 0, then let's say we have an answer stored. Seeing how to remove the last element. Oh, I got it. So go here to answer. Your answer would be your answer vector minus, oh my gosh, minus length of answer. So this code right here would do it if you're, and then you'd want to like return answer at the end of your code. So does this make sense what I'm doing right here? If somebody, so this will get it to match right there. If somebody enters in a lag that is not divisible by 1, so they're entering in an extra decimal, then the answer they get is going to be their answer minus the last element, which is the length of the answer vector they're getting. So that's going to subtract off the last element of that vector right there. Does that make sense right there, Jarius? So you could get this to work right here the following way, which is going to then remove off that last answer because what they did. Yep. So I'll drop that here in the chat. Really good question. Everything should be working. I think it's just an issue with the way, maybe the person who wrote, I'm trying to remember who wrote this one, but you could have 0.8 on there. But yeah, you could get a custom warning message. So print that warning and then say like, you could say like, we removed the last element because we rounded up on you. But I think it runs that way right there. A lot of time the way it's written, I think you can write it some ways where it doesn't do it, but you could remove that element with this right here. Just, oh, and then you want to do this. You want to store it over answer. Sorry about that. Don't forget to overwrite it. So you want to test your code to make sure that it's overwriting what is in the answer. So if the lag is not divisible by 1, because the remainder of it is 0, then take what was in answer, overwrite it with what is in answer, minus the last position of answer found by the length. So, yup, it's all these little things. I tried to do as integer and round in it and still got the same things. So it needs to be something to remove the last element. Yeah, just like cut it out. So that's what we do right here. Jarius, great work right there. It's just these little things. We were debugging some functions earlier, and it's just a practice. It's just the practice about getting it to work. Thank you so much, Shreya and everybody. You're welcome. Yeah, I'll be answering a lot more questions on Discord, trying to see if we've updated anything about assignments. But a lot of great work. I'm going to head over to a meeting here in a moment. Thank you so much, everybody. Here was our full day of fun. You're welcome, Shreya. This is everything we did today. We had office hours. We had class. We had class. We had class. We have another office hours. But we got a lot done today. Huge shout outs to the Business Analytics Forum and to everybody just doing some really awesome stuff. Until then, bye for now, everyone. Bye.